Hello viewers, welcome back to my channel. Today we are treating a very important topic under the Jamb past question series, and that is the calculation of Avogadro's number. So let's consider the first question. How many atoms are present in 6 grams of magnesium? Magnesium has been given, the atomic mass of magnesium has been given to be 24. The Avogadro's number is 6.023 times 10 raised to the power 23 atoms. Now, if you are asked to calculate the number of atoms in a gram or certain gram of an element, depending on the kind of element, just take note of this. 1 mole of any element, whether a gas or whether a gas or a solid, the 1 mole of that element contains 1 Avogadro's number. And the Avogadro's number is a constant that is given as 6.023 times 10 raised to the power 23. But this question is not in mole, it is in gram. You have to calculate the number of atoms in 6 grams. So we need to convert the mole, we need to convert this mole to gram, because 1 mole of any element contains 1 Avogadro's number, which is 6.023 times 10 raised to the power 23. But 6 grams will contain what? Now, we don't know, because we were not given our questions in form of mole, so we need to work it out. So 1 mole of magnesium contains 1 Avogadro's number, which is 6.023 times 23 grams. But we need to convert 1 mole of magnesium to mass. 1 mole of any element is its atomic mass or mass number. That has been treated in the previous topics. So 1 mole of magnesium is its atomic mass, which is 24 grams. So 1 mole of magnesium is 24 grams. So I will gladly write 24 grams here, meaning that 24 grams of magnesium contains 1 Avogadro's number, which is 6.023 times 10 raised to the power 23 atoms. Since 1 mole of magnesium contains 1 Avogadro's number, it means 24 grams of magnesium contains 1 Avogadro's number. So 6 grams will contain what? How did I get this 24? 1 mole of any compound is its atomic mass. So the atomic mass, which is also known as mass number of magnesium, is 24. It has been given in the question. So 1 mole of magnesium is its atomic mass, and it is 24 grams. 6 mole will contain what? So we can cross multiply here. So we have 24 times x equals to 6.023 multiplied by 10 raised to the power 23 multiplied by 6.0. So dividing both sides by 24, we have x asks 6 here 1 here 4. So our answer is 1.51 times 10 raised to the power 23 atoms. So having done that, we have another form of question here, and that is the number of atoms in chlorine, of chlorine present in 5.85 grams of sodium chloride is what? Now, considering the question, it is similar to this, but this element given here is sodium chloride, and sodium chloride contains 1 mole of chlorine. So we can say here that 1 mole of sodium chloride contains 1 Avogadro's number. That is 6.023 times 10 raised to the power 23. Calculate the number of atoms of chlorine present in 5.85 grams. Now, 1 mole of sodium chloride, which contains 1 atom of chlorine, is 6.023 times 10 raised to the power 23 atoms. But in the question, we are not working in mole, we are working in mass, which is in gram. So we need to convert 1 mole of sodium chloride to mass. Now take note, 1 mole of any compound is its molar mass, just like 1 mole of any element is its atomic mass or mass number. 1 mole of any compound is its molar mass. So we need to work out the molar mass of sodium. The atomic mass by adding the atomic mass or mass number of each of the elements. So Sodium is 23. It has been given in the question. Chlorine is 35.5. Adding these together, it contains 6.023 times 10 raised power 23 atoms. Now, that is 58.5 gram contains 1 mole of chlorine. That is 23.5 grams atoms. Now, why did I use 6.023 here? If I have more than 1 chlorine in sodium chloride, I will multiply this number by 2. But I have just 1 chlorine. That's why I'm multiplying this by 1, which does not make any difference. But in case you are working with like a tetrasulfate 6 acid like H2SO4, in this case now you have two hydrogen ion here. So the number of moles will be multiplied, the number of atoms, that's Avogadro's number, will be multiplied by 2. So in this case now, 58.5 gram contains 1 Avogadro's number. So from the question, 5.85 gram will contain what? The first line here, I got it from the equation given to me, from the information given to me, which is 1 mole of sodium chloride, which contains 1 Avogadro's number multiplied by 1 because it contains just 1 chlorine. So 5.85 gram of sodium chloride will contain what atoms? So we can multiply here. We have 58.5 times x equals to 5.85 gram times 6.023 times 10 raised power 23. Dividing both sides by 58.5. X will give us here 1 here 10, 6.023 times 10 raised power 22 atoms. Now, the answer here is, the best option is in option A. Now, you can work this out and get your answer. And if you are yet to subscribe to my channel, don't forget to do so. Subscribe, share my video, press the like button, and make beautiful comments. And watch out for my videos on calculation of mass and volume relationship.